Let's hope it doesn't go bang. It went bang. Drat. Today on Gumtree, a JBL 120, I'll put the model number here, subwoofer came up. It's a 12-inch, 400 watts RMS. It's faulty. The owner said he actually picked it up with a whole home hi-fi system, and when it arrived home, it wasn't working at all. So I picked it up for $250. This would have been well over $1,000, closer to $2,000 when it was new. It's a 12-inch. About 26 kilos for this unit, better than anything I own. So I just had to pick it up and see if I could take a crack at fixing it, and I'll just document the whole process and see how we go. So first of all, a bit of an inspection. It's going to clean up like new. That's not a mark there. There's a tiny little blemish over here. It's very dusty, like at the front, and the top of it was dusty too. I happened to rub it down before I even started this video. Dust in the port in the back, and other to that though, like it's just dust, right? This thing is spotless. Gorgeous piece, definitely worth restoring or taking a good slog at it. Can't wait to pull it apart and see how this thing operates. Actually, I should add, the only thing that's a little bit kind of worn on this one is this front grille. The markings coming off. It's fine. It's just going to have to be probably recovered, I guess, if it has to go back on. But you know, even without it, looks schmick. Okay, so step one is I'm going to plug it in and test it out, because we'll see what's going on. The seller did say maybe he was doing it wrong. I think he was trying to be optimistic, and he wasn't into DIY repairs himself. He did have a friend that he said could probably fix it for him, but the wait was like 12 months for his mate to get around to it. So he thought he'd just move it on for cheap, which I really appreciate. Let's see what we get here. So power on there. Okay, red is standby, and I don't know if you can see that, but that's a red light there. So yeah, we've definitely got power. Turn that off, yeah, it went off pretty quick. Turn it on. Yeah, that's on standby. I'm going to add an audio source. Phase is 0 at the moment. Input is LFE, low frequency. That'll be to do with the cutoff filter, I'm pretty sure. LFE. Anyway, we got the volume control. You got the crossover frequency level here. Yeah, we'll see. And also, those are your two inputs as well. The biggest criticism of this model actually on all the reviews was that it doesn't come with like the speaker in out pairs, so you actually have to run this from a line level source, which I prefer to do anyway, because you know, when you have some nice hi-fi speakers with really high quality binding posts on your amp and you run them into these tiny little terminals, you know, through your subwoofer, it kind of defeats the whole purpose. So yeah, I don't think that's a problem at all. Oh wow, I was just fishing around for cables and it started making this clicking noise, so yeah, it's just mainly like a relay clicking. It's slowing down. Can't feel anything. Oh, it stopped itself. Isn't that strange? Okay, and now we're green, so it thinks it's turned on. Okay, I'm going to get a source into this and see what happens. Okay, so here I've got my high quality music streamer with an audiophile grade crappy cable running straight in there, and there's just nothing. So well, I've got that on LFE at the moment. Okay, maybe I gotta get it to normal to set to the line in. Still nothing. Okay, interesting. Well, hit it back to LFE, plug the signal into there. It was hard to do it through the camera. Yeah, nothing at all. And even like here, you usually hear like brrr, you know, the noises, especially if I unplug it here usually and touch it, you know, you hear some kind of a AC 50 Hertz going into it. Nothing like that, so there's just no amplifier power at all. Let's get this thing opened and find out what's going on. Pro tip here, JIS screwdrivers. These are so good. Look at, if I put that in there. If you've got issues like stripping screws, look at that. Like, it just fits so good. You don't strip your screws. Not for all screw heads, but so good. You don't even have to put lots of force into these to operate them. So it just works. It just slots in there so easy. JIS screwdrivers, they're amazing. I wasn't sure how I was actually going to remove this panel, taking out all of the screws. There was nothing to really grab purchase on to get it out. I tried pulling the whole cabinet back and bouncing it around. I ended up just plugging this in and kind of yanking on that to, you know, get it out. So that was the trick there. So I can grab one there. Kind of. That is a giant toroidal transformer down there. That is nice. Okay, I can feel there's a tight cable in here. They tend to do this. I'll Oops, I'll see if I can unplug it. That's from down there on the main circuit board. Focus, there we go. So I'll unplug that cable and I'll have the whole module out. All right, now here is the whole module. It looks like we've got, okay, so you got all your tone controls and preamp on this side and audio inputs. And that feeds across to this side where we have the Class D amplifier module. You got some transistors or MOSFETs all sandwiched against the heatsink there. And that heatsink is also kind of pressed against the back panel as well to add a bit more heat sinking. We've got this whole power supply section in here. Now, it's got, oh, okay, here, interesting, look at these. These are looking a bit bulged. See how the top's kind of poking out on them? We've also, I think that brown stuff, well, I think that brown stuff is okay. It's a curious choice for a color because it looks like it's all charred and burnt, but I'll report more on that later. None of the circuit board down here looks burnt. So yeah, those capacitors definitely look like they've had it. I'll get the ESR meter and test them out. Just look at that awesome transformer. Oh, it's just so tall. It's a really interesting shape. Everything under here, under the circuit board, maybe a little bit of brownness in the middle there. Yeah, looks a little brown. Yeah, okay. Also look in here, this is like the cavity that it came from. This is already sealed. It seems to be sealed. And yeah, it's coated in this like copper spray as well. So that'd be for the RF shielding as well. Make sure no noise gets into the system. This is like a kind of a smooth sealing gasket around the outside as well. So yeah, it seems like really good quality. Also down in here, if I get my nice audiophile LED light, you can see a little bit of brown in there as well. You know, it's a little bit concerning. So yeah, there could be something blown in there as well. I'll take a look and see what's going on. You know what, I figured why not try and pull up the service manual, and don't you love it when you can just find a service manual straight away. This is going to give us all the information we need on how it operates. I can look down here for a, this is the first look here, but yeah, all diagrams about how it operates. Here we go. These are all the components on here. Part numbers. This is perfect. Okay, yep, we're going to have a lot of fun with this one. Okay, so this is the power supply section with the bulging capacitors. And we've got two separate rails here. So this one has 2,200 UF capacitors. I think they were the little small ones. And we've got the 6,800 UF capacitors here. Good opportunity to test out my latest, most favorite tool, the capacitor tester. Does all the ESR and everything in it. Makes sure that they're not just measuring their capacitors, but also measuring like if they're you know, got a high internal series resistance and not doing their job well. So I'm going to start poking around and catch some readings. Let's start with the little blue ones first. Turn that on. Monitoring for component. Okay, here we go. So put that onto there, and it says, oh, 2 ohms. In circuit leaky, it says. Interesting. Yeah, it is in circuit, so that's fair enough. But yeah, I'll try press it again. And yeah, 2 ohms. Okay, fair enough. Now, these grounds are connected together. I'll try this one over this side as well. Just over here. Let's go. 1.76 ohms. And it also thinks that one is leaky. Yeah, look, that feels high to me for a capacitor of this size. Oops. 1.7. Okay, cool. Now let's try the big ones. So now, see these big black ones here. I'm sure that ground will be common on them, so I'll put that one there. The big 80 volt capacitors. And we're going to get 6,500. That's close to 6,800 and 0.06 ohms. That's good. And try this one down here. Sorry, I'm just doing down there. 6,500. That's close to 0.02 ohms. Wow. I'll go back to the top one again. Yeah. I mean, that's good. These are big black ones, although I thought they showed maybe some signs of bulging a tiny bit. No, they're fine. These ones are the problem here, I think. I might pull them out of circuit and have another test. Okay, so here is a little capacitor. Gonna catch them up. And there. Turn it on. So here we go. Okay. So ESR 1.48 ohms. Leaky in circuit. This is not in circuit. This is out of circuit. And it's saying it's in circuit and leaky. I think this capacitor is buggered. Yeah, no way that should be 1.48 ohms. And it is definitely 2200 UF 35 volts. And it's a Yecon. I'll see if I can find a replacement for that one. Okay, let's test this one as well. Analyzing. 1.37 ohms and leaky as well. It won't even tell me how many UF it is, like what the capacitance is. Yeah, these things are buggered. So hopefully I can just swap these out and see what happens. Low ESR, okay. Okay, so I could order replacements off DigiKey. If I do that, I'll probably look for something that has similar specs, like a similar diameter, similar pin spacing, of course, you know, at least 2200 UF and 35 volts, and it's going to have to be a low ESR replacement. Although I've got a junk box and I've had these capacitors since I was a kid. They're 50 volts, so that's more volts. These were 35, and they are 470 UF, and most importantly, they're both blue as well, so they must be a reasonable drop-in replacement, right? So we'll see how these go on the ESR meter, because these are so old. They may be 20 years old. They may be older than the amp, but they've been just in storage, so we'll see how they go. Here we go, analyzing. Yeah, 458 UF out of a 470. That's not bad, and 0.1 ohms ESR. Also, well, they're about a quarter of the capacitance of what I need, but I think I might have some more of these. I may be able to parallel them and get about 1000 UF at least. It's a lot more than we had before. Maybe enough just to run this amplifier. Okay, so here they are, soldered in quite loosely at the moment. I'm just gonna see if it helps the whole unit to power up. So I'll plug in the speaker again, just give it a shot. Off, plug it in, like that, okay. Turn her on, and on here as well. Okay, we got red, we got green, red. It's not fixed yet, that's for sure. Okay, so back to the service manual then. They have given us a nice troubleshooting flow chart. It starts with there's no signal output. Okay, first check DC voltage. Is there DC voltage? So I was checking on these main capacitors in here, the big black ones. They're 80 volt rated capacitors. I was getting 74 volts on the meter. So that there is, yeah, we're good. Do you have VCC? Yes, we do. Okay, do we now check the plus minus 15 volts? That'll be the little blue capacitors down here, VCC plus and minus. So the 2200s I just replaced these guys here. So I'm checking the voltage on them. And it's funny, when I check the voltage, like I touch it, ready? It's gonna stop. Oh, well, it's not ticking now. Okay. It stops when I touch it. See that? Now it's going. Oh, now it stopped on its own. I don't know. It's definitely possessed. But anyway, there is a good voltage, about 28 volts across each of these. And they were rated at 35 volts. That makes a lot of sense. 28 volts is good. So we do have supply voltage there. And yeah, I'll go back to the troubleshooting. Okay, so I was meant to be following the troubleshooting guide, but then I realized like there's this other capacitor down here, just below the relay, the blue relay. You can see that black capacitor. It's a 220 UF. And I thought, well, because the board down there is all discolored, maybe this guy's got some issues. Now let's see if we can just touch those on there. And what we got? Open circuit, low capacitance. Well, I just took that off then, but yeah, this capacitor down here, open circuit, low capacitance. yeah, I reckon I got to change that one too. Just the way it's flicking on and off, it feels like, you know, a capacitor or something. Let's give that a shot. I had to knock off early last night, didn't get much time to really look into this, and I've been thinking about it a bit in the back of my mind today about things I'd like to check out and continue trying to troubleshoot this repair. Also, last night after I knocked off, I got online and started ordering some replacement capacitors. So for all the electrolytics that seem to be drying up and not working, like the dodgy ones I've just been shoving in there, I've got actual proper good brand name ones on the way. They'll come from RS Components probably in about a week or so. But for the meantime, I'll just keep troubleshooting and see what I can find. Okay, so while I was thinking about it today, noticed how these capacitors were terrible, and I've kind of swapped them with some crappy ones. This one down by the relay was rubbish as well. I ended up swapping that one out. And look down here, I was thinking about this. There's an NTC thermistor in there and two resistors that are covered in that kind of brown schmoo. And they seem to talk to the cutout circuit. Basically, if the heatsink overheats, it turns off the whole circuit. So what's going on there could be related to, you know, how when you first turn it on, it doesn't turn on, and then it starts flicking on and off and on and off. Maybe as something heats up. So that's something that I'm going to look into a little bit. And also these two capacitors here as well. I thought those are, look, if these ones are overheating and bulging, these ones are definitely overheating. Like they've got to be terrible. So I got out my ESR meter and let's whack it on them. Here we go. So put them onto there. And what do we got? Yeah, leaky again and 10 ohms of ESR. Here we go. So if you go to the one beneath as well, hold that on there and we get also leaky and 14 ohms. So that's pretty bad too. I'm going to pull them and change them because if I look at the circuit, that's these two capacitors here in a row, 156 and 157, 220 UF each. They seem to be involved in this circuit. That's the PDS there. I don't know what that stands for, but that seems to be like the shut-off safety circuit output there. And look, I haven't gone through exactly how this operates, but they're related to it and they're dead, so I might as well swap them out with something I've got. You know what? I'm actually gonna do a whole lot of capacitors. Here's my old capacitor drawer and a bundle of different values that I've got laying around. Although these aren't amazing low ESR capacitors, most of them don't need to be in this circuit. And look at how dark this is, that green there compared to say the green over here. You know, it's gone brown, almost black. And look on the top of the board here as well. You can see it's been charred, right? And I've tested all of these capacitors in here as well, and they're all leaky. Most of them can't even get a capacitance value on the ESR meter. So while I'm going to change these two, I'm also going to change all of these. You can just see how much temperature they've had. And yeah, I'll do that process and see if that changes anything. There you go. Okay, so I've just taken this component out. This is a 220 UF 10 volt, and it came out from down here near the heatsink. And we are getting about half of the capacitance value and 7 ohms. So that's not ideal. I'll try the other one as well. Okay, and this is the other one, 124 and 7 ohms. So almost exactly the same wear on both of them. You know, 128 and 124, and they should be around 220 UF. Probably about half an ohm they should be. So yeah, they've really taken a beating. Thankfully, I have a ton of 220 UF 10 volt capacitor replacements here, and these ones are measuring 200 UF, so they're within spec, about 10% down. Usually even 20% down is okay. And we've got about half an ohm here, so that's you know, about 15 times less resistance in it. So I'm going to solder a couple of these in near the heatsink and then work over to this side of the board. So there are the new ones in there. That's 157 and 156. These were the ones that kind of feed into this transistor network here and maybe controlling the shutoff. Well, just to add, like, at the moment I could be going through the whole troubleshooting process, but given that there's been so much obvious thermal stress in here and that these capacitors are measuring, you know, at a 15th of their recommended ESR, there's no real point in proceeding trying to find any one fault while all of these things are completely broken, just in my opinion. It means that I can troubleshoot knowing that the rest of the circuit is doing what it's meant to do. And the next ones I'll do are C166 and 167 in there. And these ones are part of the plus and minus 15 volt rail bus. I've got proper replacements on the way, but for now I'll just stick in some, I think I've got some 220 UF 16 volts that'll fit in there nicely. This is C166 that came out of the corner just in here, where it's very charred on the circuit board just down there. It's not even a capacitor, it's nothing, you know, so it definitely needed to be replaced. And these new replacements, 220 UF, 16 volts, yeah, close enough to 220 there, just a little under, and 1/4 of an ohm ESR, so that's pretty good. And here is C167, also 100 UF, 16 volts, and not measuring anything. It's as if it's not even there. And this is C161, 22 UF, 50 volt capacitor. And again, monitoring for component. It's just not there. So we'll swap that one out too. Okay, so I've replaced all of the electrolytics on the main board now. And next, I just checked these ones as well on the amplifier board. Look, they're about 2.2 ohms, which doesn't sound great to me. I'm gonna plug it in now and see if any of this has made a difference. Okay, it's all plugged in again. Running to the music source. Okay, so green is on. Interesting. I think that's different. I thought before it was going into standby. And I did hear it click too. It clicked the relay. Whereas before it would be red for a long time and then start click, 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 click really intermittently. So that's good. Give it a shot. Nothing. Okay. Well, we're not there yet. But we're making progress, because that light isn't flickering around and going crazy. Okay, so with the amp still not working, but having replaced all of the capacitors now, I'm coming back into the troubleshooting flow chart, and let's run through this. There's no signal out, that's correct. DC voltage check on plus minus VCC. Let's find out. Is plus minus VCC correct? Let's find out where VCC is. Here. Okay, so on the 2200 UF capacitors. So that's these ones that I replaced here. And I'm just going to quickly check. What are we getting here? I can go from there to there because I get negative voltage because I've got the plus going to the minus here. Oops, that's right there. Minus 28 volts. Yep, that makes sense. So VCC is 28 volts. I could check this one as well. Confirm that the plus and the minus are the same thing. And that is also 28. So yeah, these rails are good. VCC is correct. Okay, let's go back to the troubleshooting chart. Okay, check 15 volt rails. Okay, so they would be on the C166 and 167 that I replaced. I think they were over this end here. Yeah, so there's just these two down here. I'm getting 14.49, 14.5 volts, that's all right. And down here also, yeah, 14.6 volts. Yeah, sure, that's close enough to 15, especially considering they don't use, this is how much they've cheaped out. This isn't even a real regulator. This is how they're getting the 15 volt rails. From 28 volts down to 15, you know, doing it the old fashioned way. So it's not very accurate, but hey, it'll do. Let's go back to the troubleshooting again. LED light, green or red? It was definitely green, wasn't it? So let's go down to here. We've got to check P104 pin 8 signal. Okay, so P104 is an EQ circuit according to this little schematic here. And it's just a couple of op amps, a bit of a filter here. No variable resistors at all that I can see. So it's not even hooked up to the external enclosure. And if we look in here, basically P104 is this little header here where another board is soldered in, the board has this little op amp on it, and it doesn't label what pin 1 and pin 8 are anywhere, but basically one of them is the input, so either the top pin is the input and the bottom pin's the output, or it's the other way around. And they're asking is there a signal, so I'll just measure both of them to see, like on the oscilloscope, and see if a signal's getting to either of them. Okay, so I've got my little oscilloscope hooked up to ground there and a signal at this end, and you can see a flat line there. I'll just start the music playing on the source and you can see it there. Stop the music. Okay, it goes flat again, that's good. I'll try the bottom pin as well. There we go, so that's on there. And run again. And there you go, you can see the waveform. Okay, stop that, cool. So yes, we can answer that question. Yes, there is a signal coming into pin 8, whichever end that is, because it's coming through both ends, which means we've got to check the limiter circuit C151. Okay, we'll get to that one. And C151 is just here on the edge of the board between the two connectors. So check that out. That's this one here. Let's see how it's performing. Okay, so here is C151 on the schematic, and it's part of this whole audio limiter pre, they call it here. And you know, we've got a bundle of op amps, and C151 is the output. That's going to go to TO4. So I think what they're trying to say, like, is I checked the capacitor, it seemed fine. It's about 20 UF and a couple of ohms, not bad, especially for a 50 volt capacitor. Now, I'm pretty sure they're trying to say, work out if there's a signal coming through there, and which I can do by playing my music, and you'll see, yeah, beautiful audio coming through. Stop that, goes flat again. So yeah, I think that's good. There is a signal there. So the next step then is test J111 signal, and that's a bit strange. It sounds like a jumper, but when I searched the document, J111, the only reference is a J111 FET, which is actually Q107. So we're trying to test a signal at Q107, unless there actually is a J111 jumper. And here's Q107, a little FET hidden in there, and it is here as part of the limiter pre-circuit. And I'm trying to work out what it does. It seems to take an input from the header and it can shunt it to ground basically before it goes through these op amps getting to that output signal that we know where there is a signal. It can be driven from this circuit here that seems to be doing some kind of possibly monitoring the rails and then using this FET to mute the signal until the rails are ready, looking at what's going on there. Also, it's driven from, you can see that minus 15 volt rail going through a diode, and that's also going to be able to turn it off when the minus 15 volt rail goes down to minus 15 volts. So it just seems like a startup mute sort of a circuit going on there. So given that this seems to be some kind of a muting circuit from my cursory inspection, and also knowing that there's a signal that's coming out through here as we tested through C151, then I'm going to go back to the troubleshooting diagram and just start looking around for what sorts of things it could be related to. So we're back here at J111 signal. Like, I don't know, is there a signal? I could try and test the signal on the gate and see what's happening. If there's no signal, we're going to have to check the supplies, and those are the ones that should be driving it on or off. So it seems that J111 really is meant to be checking supplies and muting things if they're not good. So this makes a lot of sense. I'm going to look into them, and this tells me how to fix it if there's no supply there. Otherwise, the only other step is the 300 watt module, that whole this circuit board in here, which is, look, I don't want to have to pull this thing apart, and there's all, you know, high frequency switching, and there's all like thermal grease in there and things. So, well, I'm going to check these supplies over here and see if there's a problem. Okay, so the thing is, VBB, that is they're telling us to test. That makes sense. Like if there was bad buses here, that this would be muting everything. So I still have to check the gate of that and see what's happening. But the trouble is, if I go down to the power supply, VBB is this one with the big capacitors, these big black ones here, and I already tested that earlier on, and it seemed to have a good steady voltage on it, which means that it might be this module after all. Oh, see that smoke? Oh, when you turn on the power and something just explodes and fizzes. Bright sparks. Well, I don't know what caused that one, but yeah, I'll look into that. Gee, there's a bit of a, yeah, I just turned it on. I wanted to see if the, make sure that, you know, the LED was definitely going green. I was going to test these ones again. There's nothing like metallic touching here, nothing to short out or anything like that. That was all safe, I checked it. But yeah, the moment I turned it on, just out of here, just fizz, and yeah, it went kabang, so I turned it straight back off again. Okay, well, now there's even more to look into. Okay, so I'm going through here, taking out this whole amplifier board because of the explosion, and just noticing here, like this cable tie down here on the inductor's fallen off. Could be a clue. Okay, so on closer inspection, these cable ties that were kind of holding the inductor in place, they're just falling apart. They're just brittle. Look, they've just been burnt through, really, over their time, and yeah, they're not so good anymore. And even this little black stuff under here as well is just all coming out. So there's been a lot of heat in here over time. Now here's a close-up of where the smoke came out. If we look at this guy here, it seems it has split apart. This capacitor, it looks like bright blue light coming out. And looking at everything else on here, like, it's all charred, but I don't think anything here looks physically blown up. I think it's just the capacitor has expelled all of its flames across the rest of the circuitry. So I'll give it a good clean up and see what it looks like then. After a quick clean up, I can see, look, all these resistors are all fine down here. There's still some shmoo on the legs of this guy, but I think it's going to be fine if I clean it up. I think I should really disassemble this and give it a good cleaning. It'll also be a good opportunity for me to reinstall all of these capacitors that I swapped with new fresh ones that have arrived from RS Components, all high quality ones. Looking at the job here, so we've got this amplifier board with a couple of FETs, and I'm not sure what the third one is in there. We can see the thermistor stuck to the heatsink down there, so all that stuff was worrying me. Now it's not so much. I realize it's just some kind of potting glue to hold the leads of that thermistor in place safely. So, like, I could take off the heatsink. There's two screws underneath, and I'd have to peel off that thermistor, but maybe I don't need to, actually. I think I've got these two screws going through this kind of spreader, equalizing the force across these, going straight into the heatsink. If I take off those two screws, I should be free then to just remove this circuit board while keeping the heatsink in place by removing these three, and these two pins underneath. It's not going to be easy to heat all of them at the same time, but it wouldn't be any easier with or without the heatsink. So I think that's the next step, to get this board out and really clean it up, and also to test these two capacitors as well, because I know, look, 100 volt capacitors, I measured them. I wasn't too happy with their ESR. So yeah, I might look at swapping them as well. And I've just taken out these two screws now, and this has just come straight away. You can see these little insulators here. They're really thick, actually. Yeah, just easily popped off there. So now I've just got to take out those pins and remove this whole board. Cool, that was nowhere near as hard as expected. I've just taken out these 3 sets of leads, and this board is out. And let's have a little squeeze at it. Yeah, there's a lot of black gone all directions on it, so I'll give it another good clean out and test some capacitors. Yeah, you can feel that's cracked. Oh no, Geez, that's not cracked. That's just some stuff on it. Well, I'll test that one as well. 105s, that's 1 UF, I think. Okay, I've just been scratching off a whole lot of all this black stuff from around here and between the capacitors. It occurred to me maybe this stuff is glue and it's just gone black over time or something, but now I'm starting to really get in here. You can see like all this bare copper underneath, so no wonder something's shorted out and gone bang. Gee, even the jumper here is a little bit charred, so I think that's where the bang happened. Even this, I can feel a groove in the circuit board where this has all happened. Yeah, it looks like maybe, I don't know why it happened when it happened, but it's kind of shorted out across all this black carbon stuff, and that's what's caused the big bang. Just inspecting the underside of this little module as well. This is where it's all driven from. It looks pretty clean, however we do see a lot of this black stuff again, kind of this glue that's maybe gone black over time in a few places here, and that could be a concern for the future, so I'll go about seeing if I can clean some of that off as well. But overall, it's a bit interesting what's going on between those two pins there, but overall it's pretty clean under here. I was just testing the conductivity of all this black glue stuff that's come off as well, and I was getting sometimes around 3 megohms, sometimes less than 1 megohm, depending on how I held the probes on it. So yeah, that's not a good sign. I'll definitely go about trying to clean it all out. Okay, I'm about to knock off for the night. I did look up on the internet about this module here with its name, the subwoofer, digital subwoofer 104DS 30001V-E. And you can see down here where the circuit, it's just blasted apart the trace here, especially around this pin. And yeah, a lot of people have issues with this subwoofer module. Apparently it's out of China. The manufacturers won't share who actually makes it, although we do have a schematic for it. It's used across a lot of JBL and Harman products. So you know, a lot of issues with this type of module. And you can also see on the bottom of the pin here how it's gone black just there as well on that pin. So yeah, that seems to be where everything happened. Also, I tested this capacitor here. These are both 10 UF 100 volts, yet like this one's kind of green, this one's kind of black. I don't know why they're different colors, if that happened over their lifetimes or if they're just from different batches, but this one measures really bad. Like it's half a UF instead of 10 UF. So look, that having no bulk capacitors on the supplies to this thing that's probably switching at over 100 kilohertz, not having capacitors on it is going to cause all kinds of troubles. And it was mentioned online as well that these capacitors tend to go on it, and with the temperatures, it's making all the glue turn to carbon. Yeah, they're not expected to last that long in these conditions. So yeah, I guess replacing them with some high quality ones would probably be a good move too, but it's a bit hard to find this value, so I'm probably going to have to do another RS Components order to get 100 volt versions. And here we go. I've just soldered basically a resistor wire on there. It's only a short little trace connecting the header pin to the PCB trace. Okay, so it's a new day, and I'm just going to replace a few capacitors. Now, some of the capacitors I ordered from RS Components still haven't arrived. They tend to break up your orders and ship things separately. So I went to JCar today just to pick up some spares. So for these two that are only 470 UF, I'm going to swap them in with some nice 2200 UF 50 volt capacitors. And on this side, this is the main ones I had to do. These are the 10 UF non-polarized caps on this little board that I've repaired. And these are 100 volt non-polarized 10 UF crossover capacitors used for building speakers. Like they're meant to be pretty good. They're not, look, how can I put it? They're meant to do audio signals, and the output of this that we're actually filtering down to audio signals could be in the hundreds of kilohertz. So it's not perfect. However, I would be very surprised if the capacitors that were already in there were better than what I'm going to replace them with anyway. Okay, so I had to solder this bottom capacitor on its side just for clearance issues. This top one I've got just running vertically. I've kind of insulated the leads just to make it a bit safer. And that's because when this one slots in here, down there, There were just going to be clearance issues hitting these other capacitors if it was standing upright, so that's why it's on its side. Alright, the new caps are in. Suntan brand from J-Car. Probably not the best in the world, but they are also reported to be pretty good quality, and just feeling the weight in them compared to the ones that came out is very significant difference. These ones measure at 0.02 ohms at 2000 UF, which is great. And I'll take up one of the old ones just to see what we were working with before. Analyzing, yeah, 1.9 ohms, and just not even a capacitor, it's just leaky. So yeah, about 10 times weight up. Wow, 100 times better. That's pretty good. Just getting ready to put it back in. I've got quite a thick dollop of thermal grease on the back here of the module. Going to place it in there. Alright, module is now secured in with 2 screws. They're all nice and flat, clamped down. Now I just got to put in some solder on those pins on the bottom. Okay, so now I'm nervous. I've changed every single capacitor except for these 2 bulk capacitors here, which were testing really well. All replaced, and we had that fire get out before, a bit of smoke, and now the time has come to turn it on. And I've plugged it in down here, and there's the power point there. Let's hope it doesn't go bang. It went bang! Drat! In that same spot in there again. Gotta take it apart again. Well, this is kind of silly. It burnt out in exactly the same place as before. See, that's my wire link that's burnt out just when before there was a trace that burnt out in its place. So it was probably quite silly of me not to check what was going on there and make sure that whatever short was there wasn't already removed. So, oh well, at least it was pretty easy to pull it apart. Second time around, only took a couple of minutes, and yeah, now I'll figure out what's going on in here. Okay, so yeah, it looks like this is the V in plus, and yeah, it's shorted to ground. If I can chopsticks these. Yeah, so there's a short going across there for some reason. So if I go back to the schematic, okay, where are we? So this is the amplifier module here. It's basically where V plus is coming in and just shorting out. And I've tested source and drain on here already in case that was shorted to ground. That's not it, but I'm going to go through here and see if I can find, oh, it could be this guy here as well. Could be a short to ground through there. I don't know. Okay, so I've checked here, the source and drain, they're fine. I've checked here, source and drain as well on Q10B. I thought that maybe that would be showing to ground, but this actually goes to output. This is the pulse width modulation signal that goes through the filter to the output, not to ground. So I've just got to look through here to find out what could possibly short to ground. Well, it can't go through that resistor, but I'll test it. Can't go through that capacitor. It's actually DGND, digital ground there. It could be, if C12, for instance, shorted out, that would be a short path to that ground there. I'll see, but I'll keep looking. Yeah, you know what, C12 could be it. We've got signal, we've got a short going from here down to ground. DGND out here, right? Which makes sense. And 12 is this disgusting looking thing here. Let me get some more light on it so you can see. Like, that's not looking good. There's all this black stuff around it. Yeah, I don't know if it's cause or effect. Like, did the guts come out of this capacitor and cause that? Or did all that stuff that may have started off its life as some kind of a glue holding it in place, because it's got these, you know, little bendy legs on it, short out or something like that, and, you know, grow yucky over time? Well, it turns out this guy is short circuit, at least in the circuit. So either this is shorted, because it literally goes across the pins that are shorted. It could be the cause, or it could be measuring short because something else here is shorting still. So I'll take it out and have a look. Its complement here, C14, seems fine. So, you know, it's 100 volt. These polyesters, I don't think they normally fail short circuit. So once I take it out of the circuit, I'll just keep eliminating things until we figure out what the problem is. Nope, that wasn't it. We've taken out the capacitor. and we're still measuring a short circuit there. I also tested the capacitor, it was open circuit. So yeah, that's not the problem there. That's not the cause of the short. I'll just keep looking around until I find it. I've gone through and tested just about everything here, and I've been getting the toothbrush and isopropyl alcohol and really cleaning it out. And after I cleaned it out, the short went away between digital ground and positive input. So basically it was this pin and this pin that were shorted, and I noticed that this here is part of a big ground plane here, and all of the burning has gone on really in this gap under here. That's where all of the evidence of that burning has been. So I think it's just been carbon deposits there just causing that short out. So I've really dug away at it now, cleaned in there quite a bit to really get some clearance, and no, it's measuring fine. So I'm pretty sure that's what the cause was, and it just kept burning in the same place. And I'll just put in that capacitor again that I took out and get it all built. But at least now it's where are we? It's all a lot cleaner than it was before. There's still some goopy stuff on this side, but yeah, all this side is really clean now, and I scraped out a lot of bad gunk from there. Okay, put this capacitor back in. That was rated at 100N, and I measured it on the multimeter. Got 98 nanofarads, so that's pretty cool for having had such a, put that one down too, such a difficult life in here. Still measuring well. So I've put on the thermal compound now. Gonna put it all back together again. Okay, the time has come to test this again, and if I just try and show you here, I've tested in here, made sure there's no short circuits or anything, even now that it's all put together. So we'll see what happens. Right up, here we go. Turn that up. Going to turn on the power here, and no. Oh, that was a click. That's good. That was a really click. We turned it on without it exploding. That's great. Okay, and I'm seeing green LED. Oh, that's good. Okay, I'm gonna plug in the speaker and see where we're up to. Yeah, so last night I was measuring around on the bottom of the module, the power module, to figure out why there's no audio happening, and I slipped one of the probes and caused a short, which shorted out one of the supply rails and blew up the fuse over here. It just goes in down in there. It's a 2.5 amp fuse. I'm going to swap it out, but I'm also going to just clean this one up here as well, and just going to take out that module and start playing with it on its own. Today I've been, and yesterday, just testing every single component, every connection between each component, just tracing out the circuit, making sure everything is connected right, measuring forward and reverse voltages on things, VBEs on transistors, resistances, and noting when it's not right. Like this one's 1.6 meg when it should be 2 meg, but it's in circuit, so it's going to, likely to measure less. One I picked up was down here. This guy consistently measures 3.8K instead of 2.2, so that's one that I'll replace. And yeah, I've just been going through, and I found, go to these guys, the big switching ones. I probably should have started here, and I'm measuring. Look, the other day they seemed to measure fine, and I've got little green marks here to say, yeah, no, I tested, that was okay. And yet today they're measuring short circuits, same with this one here. And I don't know why that would be, but then I've gone through to measure from the rails as well, from positive to negative, and I'm getting a short circuit across here as well. And every single one of these from gate to drain to source is shorted, drain to source shorted, drain to source shorted here as well. I'm going to start pulling them out and testing them individually, but that, having a short from the positive side, high side and low side would short the rails as well, so that would make sense. I'll just see if pulling them out makes a difference. But I've also got a nice component tester on the way, good excuse to buy a new piece of test equipment, where it's sort of like the capacitor tester that I've been using lately, and it'll be able to analyze all these FETs as well. Okay, yeah, I've pulled out this FET here from the back here, and that one is Q11 down here on its own, and it is shorted out. I've tested across, yeah, the gate is shorted, the drain and source are all shorted, all low impedance. So, and pulling that out as well has meant that positive and negative rails are no longer shorted out either. So definitely that short was running through the FETs. Thankfully, I've ordered another 3 on their way, and I'll be swapping them out next. All right, DigiKey, a new order has come in. I've got a bundle of capacitors and some MOSFETs, replacement MOSFETs. I've also got a polypropylene output capacitor there in case we want to install that one. And I've got a nice component tester here. This will be able to test for the broken semiconductors. So yeah, looking forward to getting back into this repair and swapping. I've already taken one off there. I'll test that, but yeah, I'll swap all 3 of these because they seem to be broken, but I'll test them as I get them off. All right, here is the new tool. Now, I was so happy with the last peak capacitor ESR tester that I thought, you know what, now that I want to test these semiconductors, I'll try the semiconductor tester. This one, you can apparently just connect in any order and it'll figure out which lead is which and what's on there. So let's do this for the first time. Okay, analyzing. Short circuit on red, green, and blue. Well, that's what I thought. That's what I got last time. So, hey, seems to work. So that was Q11, which we just tested. And I think it's an IRF something. But look at this. They actually scraped off all of the markings. So, I don't know if they're trying to hide what it is when the schematic's already in the service manual. Or maybe it's not even a legit component to begin with. Maybe it's counterfeit. I believe that was an IRF 640N. And so here's the replacement. Looks kind of similar. Let me focus in here. Wow, there you go. You can barely read it. So yeah, still no markings over there at all. So that's the new one. Slightly different in the middle here as well, that CKF, whereas this was number 15. This is upside down. Yeah, I think this is a slightly different version as well. So it was a 640N, and we've got an NPBF. There was a few options available. All right, next we got Q10 in the middle. Put her on the tester and see what it says. Analyzing. Enhancement mode. P-channel MOSFET. Wow, okay, scroll down. Red, green, blue. Source, gate, drain. Gate threshold 3.38 volts. Okay, this was measuring short circuit while it was in here. But I also know from the schematic, these two are almost back to back. So given that this one's not blown, I reckon that one still is blown. But I might replace it anyway because I've got a couple of spares here ready to go to good use. And now we're testing Q10B over here, expecting this one will be shorted out because that one in the middle was measuring shorted when it actually wasn't when it came out of the circuit. So turn that one on, analyzing short circuit on red, green, and blue. Perfect. Yep, that's what we thought. That one's a dead short as well. So we'll replace it with a brand new one. While I'm in here, I'm also going to change R33 as well. It's a 2.2K. As you can see, they've been kind of damaged, and it was under this capacitor here that was kind of bent sideways across it. And it's been measuring at 3.6K when I was measuring everything in the circuit. So I've got some spares here, and I'll drop 1 or 2 in there as well. Alright, there we go. Terrible shot, but I've replaced 3 of them down there. Not that top one, R34. Just because R31 was measuring a bit high in resistance as well. And it was all scratched up pretty badly. So, well, that's the view of trying to look through a microscope. And you know what? It's way clearer without even using it. There you go. Something to note here is the smaller package cases. So these were 0805s. I knew they weren't 0603s, and I got 0805s, and they're still not as big as the originals, which were probably 1206s then or something. Importantly, they are measuring spot on now, and I did a bit of math as well. It looks like the power dissipation should still be fine for them. So we'll go from there. Oh, also I'll just fix up that little tag on that capacitor as well. It looks a little bit close there, bit of a mess. Better, not perfect, but much better. Okay, so now I'm ready to reassemble. I've got to put a whole lot of icky thermal compound on all of these guys before it goes back onto the heatsink. Whoops, yep, that's a lot there. I'm going to smooth it all out as I go. Alright, and then this one just goes on top of here, lining up some holes. Yep, looks like that's just going to go there. There we go. We'll mount it to the heatsink, ready to go back onto the motherboard here. Alright, beautiful. That's all mounted again, soldered in nicely. It's surprising how well all of the pads have lasted. These two, these three, with this board going in and out so many times now. I'm going to make sure there's no short again on the rails before I connect up power. Signal wires are connected, module is installed, and I've hooked in the power cable behind, so let's see what happens. Yeah, okay, so I've just plugged everything in. Again, I haven't had it connected to a speaker yet, but just making sure nothing explodes. Next step is to kind of lob it in and connect this tiny short wire to it, and then we'll try again. Okay, so amplifier seems to be switching on reliably now. I thought, since I put so much work into the amplifier module there, maybe I'll just test the signals coming in and out of it. And I've got to be really careful not to short things out. So while it was powered down, added some terminals here. One is for ground, the one on the left is the input, the one on the right here is the output. And so now I'm measuring the signal through. It's coming through fine to the input of the amplifier module. Let's check the output now. Okay, now I'll just connect it to the output here. What? Okay, well, the amplifier is amplifying. That's really good news. Let me check at the speaker terminals. You say, okay, well, there should be something here at the speaker terminals, right? Like, where are we here? Nothing, just dead nothing. And this side as well. I'll just be careful not to short anything out. But yeah, if I put that one there as well, just nothing. So I think I have to go in for tonight, but now I just have to troubleshoot what is going on between here, and then hopefully we'll have a solution. Okay, back to it tonight. We have gotten pretty close so far. So with the ground connection here and the signal out here, I have seen a signal coming out here, and if we follow this trace, it actually goes kind of out and then around, and then it loops around, and then it goes through here across to this relay, right? So you got a pin here in the middle and a pin here, and this is the switched one out here, and in the relay's default position it actually connects back to itself, doing nothing at all, but when it energizes the relay, it connects this pin through the relay switch out to this pin here, and then that runs out to speaker terminal down here. Right, and that's one of the things that I need to test, because it could be that the relay is faulty. The other side of it is perhaps there's something going wrong here through these current sense resistors. These are the really big ones here, and maybe they're kind of faulty and going open circuit sometimes, but it looks like there's two of them in parallel, so it would be quite unlikely for both of them to fail. And so I guess that's it. So I've got the multimeter here ready to start beeping through the circuit. I've checked so far that, where are we, that of course is connected to there through the trace, and probably also through the relay as well, but also that there is no connection here to the speaker at the moment. So yeah, I'm running an input source now with some music going in. I'm going to turn on the power and we'll do some testing. So there's the power on. I haven't, oh, there we go. That was the click. And we can see green light there. So it thinks that that relay is now energized. Don't know if I can test this on camera. Maybe I can. Maybe I'll edit it out if I can't. Here we go. If I put that to here and put this to here. Well, that's interesting. I've touched there. It's connected. That is not connected. That's connected, of course. That's not, even though the switch engaged. Maybe that's where the problem is. How about that? My next step then is to figure out, is this relay actually being energized by the circuit? Now, I thought I heard it clicking on. Let's check. So it seems to have a coil here. You can see the coil there. So this is probe cam. So one is connected on that end of it. You can sort of see, I trust beneath the probe, that's where it's connected. And here's the other end. And I'm getting 20 volts, 20.33 volts over there. You can't see it. Oh, you'll have to believe me. But yeah, it'll go away the moment I let go of this probe. 20 volts. So yeah, the relay is definitely energized, yet it's not turning on. So we've got a faulty relay. All right, check it out. This is properly broken. Awkward camera angle here, but so I've got one probe on this pin here, the red one, and the black probe here. And here's power. I'm running 20 volts from a benchtop power supply. And what you're meant to be hearing is the multimeter saying, yeah, that's connecting, but it just wasn't because, yeah, this relay's buggered. So it's a bit of an odd shape. You can seem to get substitutes on DigiKey. That's going to take me a week. So instead, I might just see if I can pull this thing apart and maybe I can repair it. Alright, so here it is turned on. I'll see if I can actually turn it off. You'll see it. Release and turn on. The trouble was it wasn't actually conducting when it's turned on between this little center contact and this pin here. It just, I don't know, it must have been dirty in there. So I hit it with contact cleaner in there and then some compressed air, and then I ran some paper through the gap as well, just regular paper. And now it conducts well. So this relay is at least temporarily fixed. I'll get another one on order, but you know, just keep things moving along. I'll just reinstall this one for now. Missing its blue little pretty top, but yeah, it doesn't really need that to operate anyway. Okay, this amp just still keeps surprising me. So I can't really focus this close on this pin, but you can see my probe there. And if I touch them together, we're doing the continuity test here, right? Follow this trace all the way through here, all the way to the pin on the relay that we soldered, and look, nothing. No continuity from here to here. Isn't that crazy? Yes? No. Okay, well, to narrow this down, next step, I scratched off a bit of the solder mask here. To work out what side is the disconnect on. You can hear this side's fine, right? So let's try from this side, and no connection at all. So I reckon must be, see along that edge, must just be broken through under that silk screen or something. I don't know. How come there's no continuity from there to there? It's so close. I mean, I can always run a wire along the top. It's just so weird, isn't it? Okay, so what I've done is added a bit more. Basically, I scraped it back just like here, and then added solder across the bridge, and that seems to have fixed everything up. I think it must be just like a hairline crack along the edge near the pin, because this connector here is kind of taking the whole brunt of the speaker force every time I pull the speaker connector on and off the circuit board. So I guess it's just cracked along there, and yeah, it was just too small to really see. Okay, so finally I can test amplifier module. Nice big signal coming out there, and this little speaker terminal here. Let's hold that on carefully, and yeah, look at that. This is the first time reliably we've got audio. Okay, ready to try and connect it again. Okay, I've plugged the speaker in again. I'm just gonna queue up, get lucky, and see if it works now. There we go. Wow. I don't know if you can hear that because it's all bass. Oh. Okay, yep. Woohoo! Well, that's success. Rattle the whole room apart. Wonderful. Okay, gonna put that back together now. All right, and that's it. She's all screwed back together now. Gonna see if it's still working. Yep, beautiful. So powerful. Wonderful. Well, that's it. It's repaired.